Okay, ladies and gents, let's talk about some stoichiometry review. All right, let's jump right in here. What is a mole ratio? A mole ratio is a ratio of moles of one substance compared to another. Yeah, a mole ratio is a ratio of moles of one substance compared to another. So, for instance, in this case, I'm going to balance this up. So I have two oxygens, two magnesiums. All right, so we're all balanced now. And then it asks me, what is the mole ratio between oxygen and magnesium oxide? Well, for oxygen, I have a mole ratio of 1, 2. Magnesium oxide, I have a mole of 2 moles. So therefore, my ratio is 1 to 2. That's it. That's all you need to write. Mole ratio is the easiest. It's just looking at the coefficients in front of the actual chemicals they're talking about. So in oxygen, there's a 1 there. You know we don't like to write 1s in chemistry. And in magnesium oxide, there's a 2 there. So hopefully everybody sees where that's at. All right, how many moles of oxygen are produced when 5 moles of potassium chlorate decompose completely? And they've given me a reaction here. And so a lot of this is just reading the question right. It says how many moles of oxygen. So I know that my answer is going to be in moles of O2, right? There's oxygen. Don't write O. If it's O2 if it's a diatomic and it's O2 here, then it's got to be O2 in your equation. And are produced when I have 5 moles of potassium chlorate. So it's a moles to moles question, so I know it's going to be 1 box. And I know that I'm starting with 5 moles of potassium chlorate, 5 moles KClO3. And now it's just a matter of using the rules, which everybody should know by now. Diagonal rule. These units have to cancel. They have to go down here. So it's moles KClO3. And the units of my answer back into this top right box. I don't know how many people have forgotten that. Moles O2. And now it's just, this is the heart of the problem. This is the mole to mole ratio. So how many moles of O2? Well, I have 1 mole of O2. To how many moles oh, sorry, I don't have 1 mole of O2. I'm looking at the wrong equation. Don't do that. Helps if you look at the right equation. All right, moles of O2 right here. I have 3 moles of O2. And moles of KClO3, I have 2 moles of KClO3. Now, 5 times 3 is 15, divided by 2 is 7.5 moles of O2. Don't even need a calculator for that one, right? So there's only 3 types or 4 types of equations that we can do. We can do moles to moles, which we know is 1 box. We can do moles to grams or grams to moles, which, God help me, is 2 boxes. And then we can do grams to grams or theoretical yield or limiting reactant with 3 boxes. I'm just going to write that there so we can remember how many boxes we need to write. Okay. How many grams of iron are needed to react completely with 10 moles of oxygen? So we're going to grams of iron, grams of Fe, 10 moles. So we're going from moles of oxygen. So I know that that is equal to 2 boxes. 1 to convert from moles to moles, 10 moles of oxygen. And 1 to convert from moles of oxygen into grams or from moles of iron to grams of iron. Okay, so we're going to go forwards first. Diagonal rule, moles of O2. That's as far as I can go. I don't have a rule for what goes above moles of O2. That rule doesn't exist. But I do know that the units of my answer back in here, so let's see if that helps. Grams of Fe. Well, yeah, that helps a lot because now I'm going to use the other rule. The other rule is if I write grams of Fe below it, I better write 1 mole of Fe. Did you know how I wrote that? I wrote 1 mole of Fe. I didn't write mole Fe and then go back and put a 1. That leaves confusion for putting numbers in here. It's always over 1 mole. So whenever I write grams, I immediately write 1 mole of that same substance below it. It's just easier. Okay, now by the diagonal rule, I know this is moles of Fe. And now I just have to figure out what two numbers to put here. Moles of Fe, I have 2. And then moles of O2, I have 1. And then how many grams of Fe are in 1 mole of Fe and iron? It is 55.8. And now it's a math problem. So the way I do it is a little bit weird, but I've always just done it this way. I do 10 times 2 times 55.8 all in one line like that. Enter. And then I do divided by 1, enter, divided by 1, enter. I don't know why I do that. It's just how I do it. So it looks like I get 1,116 grams of iron out of this thing. Okay. How many moles of oxygen are required to react completely with 85 grams of iron? So we're just doing the exact same problem, but in reverse. We're just doing a grams to moles. So grams to moles is 2 boxes. I know this. And I know that we want to find out how many moles of oxygen. And we're starting with 85 grams of iron. 85.0. Sorry, I didn't write the 0. I have a bad habit of not doing that a lot. When you get into college, they're going to want to see that 0.0. All right, grams of iron, Fe. All right, so now I'm just going to go by the rules and put units into boxes. So I know diagonal rule, this is grams of Fe. I know by the grams rule that this is 1 mole of Fe. I know by the diagonal rule this is moles Fe. And I know by the rule that the units of my answer are back in this top right box that this is moles of O2. Therefore, this is the heart of my equation. This is my mole ratio. And I know that there is 1 mole of O2 for every 2 moles of Fe. And that there are 55.8 grams for every 1 mole of Fe. Remember that G stands for grab your periodic table and start adding, right? Okay, now it's just a math problem. So again, I'm going to do it the way I always do it. 85 times 1 times 1. This isn't really how I do it. And then I do divided by 55.8, enter, and then divided by 2, enter, 0.76 moles of O2, right? Is that right? Yep. Okay. Now we're going to a grams to grams one. So how many grams of iron are needed to produce 225 grams? So I know this is the Mac Daddy. This is 3 boxes. And I know that they want grams of iron. How many grams of iron? So the question is how many grams of iron to do 225 grams of iron 2 oxide, FeO. All right, now it's just putting our units in. So diagonal rule, grams FeO. Grams rule, above or below, we write 1 mole of that substance, so 1 mole FeO. Diagonal rule, mole FeO. And that's as far as I can go, because I don't have a rule for what goes over moles of FeO. So let's go backwards. Units of my answer, back into this top box, grams Fe. Now, grams rule, below it, 1 mole Fe. Always 1 mole below any grams. All right, and then diagonal rule, mole Fe. All right, now we got to put in some numbers here. So let's put in the mole conversion, the heart of the problem first, because we know that it's right up here, and we know that there's 2 moles of iron for every 1 mole of oxygen. Or sorry, not 1 mole. I gotta quit doing these late in the day and start doing them in the morning. How many moles of FeO? 2. So it's 2 over 2. All right, and there are 55.8 grams of Fe, and if I add 16, 55.8 plus 16, so this is 1 iron at 55.8 plus 1 oxygen at 16. If I add them together, I get 71.8 grams per 1 mole. Now it's a math problem. Now, you see all this? I'm going to multiply all of the top, 225 times 1 times 2 times 55.8, enter. And I got that massive number. 225 times 1 times 2 times 55.8. Now I'm going to divide by the bottom, but I hit enter each time. So I'm going to divide by 71.8, enter. Divide by 2, enter. Divide by 1, enter. And I get 174.86. Let's just hope we did all that right. Right? Okay. So that is my answer. Let's just go ahead and moles of O2. All right. After an experiment, you have 25 grams of product. That sounds like an actual yield to me. If they tell you that after an experiment, or you actually produced, or you have to weigh something otherwise, that is an actual. However, according to your calculations, you should have 33 grams of product. That is a theoretical. To get percent yield, it is actual over theoretical times 100. 25 grams divided by 33 grams times 100 is 75.75%. Make sure that when they're asking for a percent yield, that your answer is a percent. Today I saw some grams. I don't know why, or I saw some gram percents. That was really weird. So, okay, let's see what we got here. When 5.50 grams of hydrogen are reacted with nitrogen, then 20.4 grams of ammonia are produced. What are the theoretical yield and percent yield for this reaction? When 5.50 grams of hydrogen are reacted with nitrogen, H2 plus N2 goes to NH3, and we got to balance this, so we need 2 here, 3 here. All right, so I have a balanced reaction. Then 20.4 grams of ammonia are produced. What are the theoretical yield and percent yield for this reaction? Okay, so it looks like the question is asked kind of crazy, but it looks like they want me to find out my theoretical yield, and they've given me an actual yield, but they haven't said I actually produced this much. So what I need to do is find out a theoretical yield. So I need to go from 5.50 grams of hydrogen to grams of ammonia, grams NH3, right? Because they say when 5.50 grams of hydrogen are reacted with nitrogen, then, and mind you, I put the H2 and N2 because I know those are diatomic. You may not have. You better know. Go to 7 and make a 7. N2O2, F2, Cl2, Br2, I2, and H2. They're never by themselves. Okay, now after I've done that, are produced. What are the theoretical yield and percent yield? Okay. So theoretical yield, we have to work some problems. We have to go all the way to our product from our 5.50 grams of H2. So I'm going to shut this video off right here, and I'm going to do all of the next part because this one's already 13 minutes long.